Hello everyone, and here's a new video about sets and Venn diagrams. So as everyone knows, the set is the values that the set of something. Let's say the values of, for example, a set contains the values of 1, 2, 3, 4, 5, and so on. So this is a set of values of a. This means that A will contain the values from 1 to 5. This is a set of values for A. And then let's say there is, as you can see from the Venn diagram, there is a B also. Then let's say we have the values for B also. So from 1, let's say 2, 3, 7, 7 and 9. So here is the 5 values for B also. And then for all of the values, let's say for all the values are from, let's say, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So now we know that there is some common values between sets. Like for example, 1, 2, and 3 is like you can see this 2 times for in both A set and B set also. So in the time of putting values to Venn diagrams, you have to think about firstly what is the common values between two sets. Let's say in set A we have the values from 1, 2, 3, from 1 to 5, 1, 2, 3, 4, 5. And then in B, we have the values from 1 to 3, and then 7 and 9, which means we have the common values of 1, 2, 3, and here 1, 2, 3 for two sets of B. So here's the area that in Venn diagram that shows us there's an intersection between these two sets. As we know, the circles inside of the values inside of the circles will show the what values are inside of this set. For example, the things like here, the things here will show us the what values are in the set of A. Okay, so and then let's move on. Let's put the values of A, the intersection values of A and B firstly, because we have to put the intersection values and then as well to the outside of the intersection area. So firstly, 1, 2, and 3 should be in intersection area of the A and B values. So, and then 4 and 5. Here's a 4 and 5 in the set value in the set of A only, not in the B. So which means we have to put this only inside of the A. So here's the 4 and here is the 5. And here's the 7 and 9 you have, which should be placed in the place of B, set of B, but not in the place of A, which means only B should be contained here. So not 7 here and then 9 here. Only B, not A. So then we all place all the values of the sets of a set of A and B. But here we know that all the values showed by this sign. You know that, yes, this is. So then from 1 to 9, all the values should be here in this rectangle. But we put 1, we put 2, 3, 4, 5, 7, and 9. But however, we didn't put the 6 and 8 yet. So which means we have to put them somewhere. But as you can see from the sets, like there is not 8 or 6 containing any in the inside of the sets. So in that case, we have to put the numbers to the outside of the balls sets, but inside of the rectangle, like any place like here 6 and any place like here and 8. So then all of the values will be placed in the right place. So here 1, 2, 3, 4, 5, 6, 7, 8, and 9, all of the values placed, and all of the values of sets also placed correctly. So this is the normal Venn diagram, and then the normal the sets, and that can be shown. So then here we have the second type of Venn diagram. As you can see, B is inside of the A. So in that cases, what we'll see is that the values of A, let's say A set will be like, let's say 1, 2, 3, 4, and 5 again. But the values of B set will be only 1, 2, and 3. Because as we can see, the B is inside of the A, yeah? Which means the only values the B can take is the sum values of the A. So B doesn't show that the only value have like B doesn't have the unique value, that the value that differentiates him from A. So all of the area that the B can contain is the values of A. Only external values from here, let's say from here, the A can just be the outside of the B, but the B cannot be the outside of the A. So which means B can contain only values of some values of A here in the place. So and this just empty set. So here 1, 2, 3, 4, 5, 6, 7, 8 again. So so we have to put the values first. Then 1, 2, and 3 should be placed here. 1, 2, and 3. And 1 and 2 and 3 for B and for set A also. So these are cancelled, and then the 4 and 5 left. 4 and 5 for set for the A set only, not B. So then we put all the values from 1 to 5. Only left is the 6, 7, and 9. As I told you, just to put the outside of the sets, not outside of the rectangle, just outside of the sets inside of the rectangle. So that is it. That's it for the inside sets. The sets that the set is the inside of the another set. And then the Venn diagram will be represented by this diagram, this pictures. So let's say here and then now here we'll have this another type of the Venn diagram. So in that place, the previous one was the all of the values of B was the values of some values of A. But in that place, there will not be, and there is not any intersection, right? As we know from here that there's intersection between A and B. They crossed each other in this place. All right, right? In the previous example also, we know that there is there's a place that where they intersect each other, and then shows to some area that they have the common common values to share. But in this type of Venn diagram, there is not any place, there is not any area that they intersect and show to some area to put the values. So what does it mean is that there is not any intersection values for A set and the B set. For example, let's say have the values, for example, we have the values of, let's say the empty set, 1, 2, 3, 4, 5, 6, and so on. In the A set, we'll have the values from 1, 2, 3, and then, sorry for handwriting, I'm sorry. So from for B, we'll have the 4, 5, 6 value, okay. So here, as you saw that there is not any intersection value for A and B, as the Venn diagram also shows that there's not an intersection value. So we just have to put the values for A and B, 1, 2, and 3. And then for the second set, for B set, we have to put the values, just to put the values as it shows the values, numbers. And then we all put the values for all the set, like 1, 2, 3, 4, 5, 6, all of them put the diagram, and then which means we shouldn't put any values outside of the sets, just the values inside of the sets are enough to show all of the values of the empty set. So as you saw, there's not an intersection point between the A set and the B set. There's not an intersection value, like there's not any common value, common term, like there is a 4, there's a 4, and or there's a 7, or there's a 7, or something like that. Only the unique values will be represented by one set, and then this value will not be repeated again in other like set. And then you will draw a Venn diagram like this. So then it may be just a bit complicated like this, because they might give you the question like this, with the 3 sets, and then there's not any problem. Like, you will put the values, just as we learned, like the all for set the value for common for all values will be placed in here in the middle part, and then the left middle part for the intersection values of A and B, and then in the second right middle part for the intersection values for A and C, and then the last middle part for the intersection values of B and C will be placed. So here's and then empty set, and now we'll put the values for let's say we have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then 15. That's enough, I think. And we'll have the values for sets, let's say for set A, we'll have the value for like 5, 6, 7, 8, and 15, let's see. For set B, we'll have the values like, we'll have the values like 8, 9, 10, and 15. So for the set C, the last set, we'll have the values like 13, and 14, and 15 only. So 3 values are enough. And then we have to put this to the Venn diagram, have to show this in the Venn diagram form. So firstly, what we have to see is that, as we did from from previous examples, the first thing we have to look at is the common values. What is the common value for all of the sets? As I told you, the center area will contain the values that are common for all of the sets. And then, as we saw that, as we can know that the 15 is repeated in every set, right? So which means this value is common for all of the sets. So we can write just the 15 in the place for all values, and for all values common uncommon value. This is center of the Venn diagram. So then let's see what is the common between the A and B. Then this will show us what is the value for left middle area of A and B. So here is the 8 we have, and then 8 we have. So this is the only common value for sets of A and B, and then we'll put the 8 only. So let's see, is there any number for A and C? So A and C, we have from 1, 5, 6, 7, 8, and with 15 already written, 15 already written, 15 already written, just we don't need it. So 8 also cancelled. So 5, 6, and 7. No, 13 and 14. No, there's not any common value for, which means we don't have to put any value for A and C intersection part, and then the B and C, let's say. So 9 and 10, and then 13 and 14. There's not any intersection value for this also. So which means we all did is the intersection parts. Only thing we have to do is to just put in the unique values for all sets, for each sets. So A contains unique values of 5, 6, and 7. So which means we have to write the only part of the A, 5, 6, and 7. So then this cancel, just 5, 6, 7. No, we don't need to put them anymore. So then 8 of 6. So then 9 and 10, 9 and 10, 9 and 10. So 13 and 14, 13 and 14, they are also canceled. 13 and 14 canceled. 9 and 10 canceled. So here's the only values left, 11 and 12. That is not, there is not, there exist in any of the following like A, B, C sets. So we can put it outside of the sets, but inside of the rectangle, like 11 and 12, let's say. So here will be our set is our Venn diagram. So that's it for Venn diagrams, and we have to see some sort of things just for writing. Let's say you have the set diagram, let's say like this. So here, sorry for drawing if there is some misunderstandings. So here our set, A set, and then the B set. So if they ask you to find this, let's say A intersection B, intersection part will be shown with this side, like opposite of U. This sign means it is asking us intersection point, intersection. Intersection part will be asked from us. Then what is the intersection of A and B will be asked. We have to draw or shade the area, like we have to take the values from in here, or just shade the area, because they may ask to just shade area also. So here will be the area that we needed. So, and then let's say if they ask the union, because there's a common term like union also, let's say A union B. The union sign will be shown. The union will be shown with this sign, like the smaller U. Yes, let's say this is union. Union. So union sign. If they ask you A union B, this sign will show us the all of the values in the sets of A and B, like in here. These values will be asked from us, or just shading or writing the values either, but not the values from outside of the sets. Like let's say there is a value of 6 and 7 outside of the range, but the other values are inside of the ranges of A and B, and then the values outside of the range shouldn't be, outside of the sets shouldn't be written. Only the things that inside of the sets, even if it's they are repeated two times, or just even if they are unique, just the things will be asked is the values of sets A and the sets B, all of the values that are inside of one set that is asked. And then that's it. Just as they may ask you to just to find A intersection B intersection C, which is just the intersection point of 3 sets. And then they may ask you also just the union of 3 sets, which is just the all of the values of sets, but not the outside of this outside of the ranges. Here's the example. Let's say in that Venn diagram, let's say that with this previously, if they ask us the A intersection B, and then we'll have the value of 8, okay? Because the intersection value for A and B is the 8 only. We will not take the other sets, just the things the inside of the A and B range, the intersection value of A and B. I'm sorry, the 15 also. I'm sorry, 15 also. 8 and 50, because 15 also intersection value for all values. So then let's say if they ask us from the value of A union B, then the values of all of the values from A versus 5, 6, 7, 8, 15, and then 9, and then 10 will be our answer. But if they ask from us, let's say the A intersection C, here will not have any answer, because as you can see from the diagram also, there is not any common value here, right? No, I'm sorry. There is a common value. There's a 15, so there will be only 15 will be the only value for us. And then if they ask us from the, let's say the A intersection B intersection C, let's say, and then our value will be 15, which is the common for all, which is the common value for all sets. And that's it. The thing is that, and this type of in this type of sets, there will not be any intersection points. Like it's not possible to make the A intersection B. Is not possible. Here in this diagram, there's no problem. We'll have this intersection point or union point, and then in this also, it's just a normal, just intersection point, and then all of the union points will be shown. So that's it for today. Thank you for watching, and sorry for mistakes if there are any. So keep watching our videos, like and subscribe.